This is day 2 of the multiplication rule. Quick refresher. What is the probability formula for conditional probability that we talked about? Well, in case you forgot, it is the probability of A given B is equal to the probability of A and B over the probability of B. Well, since we are working on those intersections today, that and, how would I get the probability of A and B alone? Well, the trick would be to multiply both sides by the probability of B. Then the probability of A and B would be isolated, and it would give us today's formula. The multiplication rule for dependent events. If A and B are dependent events, then the probability that both A and B will occur is equal to the probability of A given B times the probability of B. So, let's start with an example. In a certain city in the USA some time ago, 30.7% of all employed female workers were white-collar workers. First of all, remember, a white-collar worker is someone that works in an office or similar setting. So, if 10.3% of all the workers employed at the city government were female, so again, white-collar job, what is the probability that a randomly selected employed worker would have been a female white-collar worker? The first thing we have to do is set up our important information. 30.7% of employed female workers were white-collar workers. That's our given statement. Given that they are female, 30.7% were white-collar workers. 10.3% were female. What's the probability of both? So our hint, F is going to be female, W is white-collar. We want to know the probability of F and W. And we know that the probability of F is 10.3%, and the probability of white-collar given female is 30.7%. Now, in order to find the probability of female and white-collar, I'm going to multiply together the probability of a female times the probability of white-collar given female. So remember, we can't plug percentages into our equations. We use the inverse to decimals. The probability of a female is 0.103 times the probability of white-collar given female is 0.307. Multiply those together and we get 0.032, which is 3.2%. That means 3.2% of all of the workers at that time in that town were white-collar female workers. Let's try one that's a little bit simpler. A college class has 42 students, of which 17 are male and 25 are female. The professor selects 2 students at random from the class. Assume the first student selected is not returned to the class population. That means they cannot be drawn for the second person selected. What is the probability that the first student is female and the second is male? So we're looking for the probability of a female and then a male. Let's start with the probability that the first one is a female. There are 25 females out of the 42 people in the class. All right, there's our probability of a female. Now for the second one, I took someone out of the class, so there are only 41 total people in the class. If we want that to be a male, there are 17 males in the class. And now I just multiply. We multiply our fractions straight across, remember? So we end up getting 425 over 1,722. And there's our probability. So try this one. Your sock drawer has 2 white socks, 4 brown socks, and 4 black socks. Find the probability that you randomly pick 2 socks and get a matching pair of black socks. So we're looking for the probability of a black sock and a black sock. Well, the probability that my first sock is a black sock is 4, since there are 4 black socks, out of 10, since there are 10 total socks. Now, once I draw out a black sock, I take it out. There are only 3 left out of 9 total socks left. To make our lives a little easier, let's simplify these fractions before we multiply. 4/10 simplifies to 2/5, and 3/9 simplifies to 1/3. Now we multiply and we end up getting 2 over 15. And there's the probability of a pair of black cards. And one more to try. Consider the experiment of choosing a card from a deck, keeping it, and then choosing a second card. Find the probability that the first one is a diamond and the second one is red. So in case you're not familiar with cards, there are 52 cards in a deck. 13 diamonds, 13 hearts, 13 spades, and 13 clubs. Those are your suits. Each suit has an ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. The diamonds and the hearts are red, the spades and the clubs are black. So that means there are 26 red cards, 26 black cards. You want to find the probability of a diamond and then a red card. So try that. What you should have done, the probability of a diamond is 13 over 52 because there are 13 diamonds in the deck. And if I keep that card out, a diamond is a red card. There are 51 cards left in the deck. And out of my original 26 red cards, there are only 25 left. Well, it would make sense to simplify my 13 over 52 to 1/4. And 25 over 51 does not simplify. So we multiply straight across and we get 25 over 204 for our final probability. And now it's time to practice.